If you're building autonomous agents, you eventually run into a wall, the cost and privacy risks of relying on external API tokens. Every interaction, every recursive thought process your agent runs is logged by a corporation and billed to your account. The way out of that cycle is to build your own infrastructure. By wrapping a local AI model in a custom fast API server and exposing it to the web through an encrypted tunnel, you can host your own endpoints. To set this up, you only need 3 things: a dedicated Linux machine, a registered domain name, and a free Cloudflare account. This configuration establishes you as a sovereign provider of your own intelligence layer. Let's get the server running. Starting in the terminal, our first step is to get the model on the local machine. We're using Ollama to pull the Mistral large language model. You can see the progress bar here as the model weights download directly to the local drive. With the model downloaded, we need it to talk to the world. This Python code block shows our fast API application. It's designed to map standard OpenAI-style requests directly to our local Mistral model, meaning any agent built for standard APIs will work with our node without rewriting its code. When we first launched the Unicorn server on port 8000, you might see some initial configuration errors. Looking at these terminal logs, you'll notice a 404 not found error on the chat completions endpoint as the routes initialize, but after a quick adjustment, the server stabilizes. Down here in the logs, we get a clean 200 OK health check response. The local API is now actively listening for traffic. The brain of our node is alive, but right now it's trapped behind your local firewall. To make it useful for remote agents, we have to build a secure bridge to the outside world. To build that bridge, we need to point our custom domain to Cloudflare's name servers. Looking at the Cloudflare dashboard, we're assigned 2 specific addresses, in this case, Demi and Rudy. Cloudflare will use these to protect our edge. Next, we take those addresses over to our registrar. This screenshot shows the Ionos management console for our domain, xifield.com, specifically the Use Custom Name Servers section. You just copy them exactly into name server 1 and 2 and hit save. Keep in mind, DNS propagation isn't instant. It usually takes a few minutes for these changes to take effect globally. With these updates, Cloudflare now manages the domain's DNS, acting as the traffic controller for your local node. Now we use a tool called Cloudflared. This acts as an outbound-only connection, allowing us to make our node public without the security risk of opening ports on our local router. This terminal line confirms we've successfully linked our machine to Cloudflare. Next, we map our subdomain to the tunnel. Warning, don't copy markdown brackets from AI chats. As shown, pasting them causes a syntax error, halting the process. Once entered correctly, the tunnel starts running. It actively listens for public requests hitting your domain and pushes them directly to local port 8000. You now have a fully secure, encrypted pipe that safely carries web traffic directly to your local AI API. We have a connection, but leaving it unprotected is dangerous. We need to lock this node down so that only your specific authorized agents can interact with the hardware. Looking at this terminal output, we secure the node by generating an ED25519 SSH key pair. This random art image verifies the cryptographic keys have been created, setting up a secure, passwordless authentication method. We then add that public key to the server's authorized keys list, finalizing the security handshake. Finally, we need this setup to survive a reboot. This screen shows the system control commands used to enable both our AI service and the Cloudflare tunnel, ensuring they launch automatically on startup. The node is now an always-on piece of infrastructure. If the power cycles, it will recover and reconnect with 0 manual intervention. It's time to test the system. Here we have a remote agent interface called Manus, sending a request to our custom domain. You can see it successfully receiving the data and completing a structural analysis of the documents we provided. Simultaneously, back on our local server logs, we can watch the incoming traffic execute and return a clean response without any lag. You are now operating a sovereign, public-facing AI backend, free of token limits, billing spikes, or third-party monitoring. Your infrastructure is in place. In the next session, we'll take this foundation and begin deploying recursive multi-agent frameworks that will live entirely on this node.